Okay, these are some exercises or some problems from exercise 5.5 Q2 on page 215 of the text. In this section, the author introduces the negation rules. And the two negation rules are quite similar, and they use a subderivation structure much like conditional introduction. So let's start with number 2, which is relatively straightforward. With the negation rules, these are also sometimes called indirect proof because the idea is that you're not proving your conclusion directly. So we're not going to directly prove not D. We're going to prove it indirectly. How are we going to prove it indirectly? By assuming the negation of our conclusion. In this case, we'll assume D. Since our conclusion is not D, we'll assume D, and we put for reductio. Reductio is another name for this kind of proof, and I'll explain why in a bit. So your assumption is always going to be, since it's a not D or a conclusion, we assume that letter without the negation. All right, notice we indented. Again, same subderivation structure. You indent. This is an assumption, so it doesn't need a justification. But now we can use it like a premise. Okay, so what are we going to do next? Okay, to finish a subderivation for reductio or for the negation rules, you need to get a contradiction. A contradiction means you have the same sentence, and I'll just use X here to illustrate. We need a sentence X and we need not X. Right? That's called a contradiction. So in other words, the way reductio works is you assume that D is true, you derive a contradiction, meaning something X and the negation of X, and that proves that D is false. Right? So if you assume a sentence and you can derive a contradiction from it, that sentence must be false. And if D is false, we thereby know that not D is true. Okay? That's the basic idea. So you need something that has the form X and something that has the form not X. Well, we already have something up here that has the form not X, namely not D and E. So what we can do is we can get D and E by combining 2 and 3 in a conjunction introduction. Now the next line down, we can put the not D, in E. How do we get that? Well, it's already up here, we have it, but we need a rule that says if we have something up here, we can bring it down here, and in the text, that rule is called reiteration. It's just abbreviated with a capital R. So we can just write reiteration of 1. Reiteration is just taking something you have above and putting it again down below. So now we have a sentence D and E, and we have the negation of that sentence, not D and E. So we have a contradiction. So our subderivation is finished, and down here we go back to the original scope line, and we write D, and we justify that. Sorry, we write not D. My bad. So we started with D, we proved a contradiction, we derived a contradiction, therefore proving that D is false, which means not D must be true. Remember, every sentence is either true or false, so if we know D is false, that tells us not D must be true. And since our conclusion introduced a negation, this rule is going to be negation introduction. And what justifies it? Again, it's this whole subderivation. So 3-5. Right? Not comma, but dash, because it's everything from line 3 down through line 5 that proves to us that not D is true. Okay? So again, the structure, conclusion is not D, so you assume D. You derive a contradiction, meaning a sentence and its negation. It can be any sentence and any negation of that sentence. Alright? Once you've derived that contradiction, you know that the original assumption is false, and that tells you that not D then is true. Okay, so that's how the negation rules work. Okay, so let's go down to number 4. Here our conclusion is not T and C, so again we'll indent, we'll assume T and C, and we'll try to derive a contradiction, which will then prove to us that not T and C is true. So first we can get T out of there. That's negation elimination of 3. Now that we have T by itself, we can do this conditional elimination. Get U. Conditional elimination 1 and 4. Remember, 1 is a conditional, 4 is the antecedent, and as a result we get the consequent. Okay, now what? Remember, we need to get a contradiction. So we have not U and C here, and we can get the U and C if we first get C by itself from from conjunction elimination of 3. Now we can put U and C together by conjunction introduction, 5 and 6. Now we drop down the negation of U and C, just reiteration of line 2. It's important that you have the you have the sentence and its negation that form your contradiction right next to each other at the end of the subderivation. So again, now we're done with this. We can go back to the scope line. Our assumption was T and C. We assume that. Sorry, I forgot to write for reductio. We assumed it. We derived a contradiction. So that tells us that T and C is false. So we know then that not T and C must be true. And again, since we're introducing a negation here, it's negation introduction, and that goes 3 through 8. Okay, number 6 now is a little trickier because notice our conclusion is a conditional. So whenever we're trying to derive a conditional, we can use conditional introduction. Conditional introduction, you indent, you assume the antecedent, and you try to derive the consequent. Okay, so now what we want to do is get H, right? We assume not I, but not I doesn't help us here at all. There's nothing we can do with this premise and this premise. So we can't derive H directly, so now we'll try to do it indirectly. So we're going to do a negation rule inside of a conditional introduction. So how do we do that? Well, we indent, but we have to indent again. We're trying to get H, so we'll assume not H for reductio. Now with the assumption not H, we can use that here to derive I. So that's conditional elimination 1, 3. So now we've got I there. We can drop down not I from up here. That's reiteration from line 2. I don't know if you need a space there or not. And that's our contradiction. So we assumed not H. We derived I and not I. So now we come back to this scope line where we indented from, and that gives us H. Now this time we got rid of this negation. So this is going to be negation elimination, and it's going to be 3 through 5. And now we assume not I, we wanted H, well we got H. So this one's done now too. And we write not I, conditional H by conditional introduction 2 through 6. So that's a little tricky. We started because we saw our conclusion was a conditional, so we used conditional introduction. When you do that, you assume your antecedent and derive your consequent, and that gives you the conditional. But when we assumed our antecedent we wanted h, there was no way to get h directly. And so if you can't get something directly, you can try to get it indirectly using these negation rules. How do you do that? You assume the negation of what you're trying to get. So we were trying to get not h, so we assume, or trying to get h, so we assume not h for reductio. Then we derived a contradiction, which proved then that not h must be false, and therefore h is true. So that gave us our h and finished our conditional introduction. So it's a little tricky. This is called a nested subderivation because you have one subderivation inside of the other. But again, just think of it like this. You can always do a subderivation, even if you're already inside one. So if you're trying to get h and you can't get it directly, do a indirect proof. That's another name for the negation proofs. Okay, last one quick. I only have 15 minutes on these, so I'll try to finish one more. Okay, this is number 8. And it looks similar, right? Because our conclusion is a conditional. So we'll assume our antecedent and try to derive the consequent. So we want not s. Okay, but we're again stuck. We can't really get anything with this assumption. So since we're trying to get not s, we'll indent again and we'll assume s for reductio. Now we can put together r and s by conjunction introduction of 2 and 3. And we can bring not r and s down by the reiteration rule of 1. So now we assumed s, we got a contradiction, we have r and s here and the negation of r and s here. So we're done with that subderivation. So we come back out to this indent line and we get s. Sorry, we get not s. We assumed s, we derived a contradiction, that proves s is false, and therefore not s is true. Since we're adding this negation, it's going to be negation introduction from 3 to 5. And so we assumed r, we wanted not s, so now we have not s. So we can go back to this original line and write the conditional r, then not s, and that's by conditional introduction. Our assumption r was on line 2, we got not s on line 6, so it's 2-6. Okay, so I hope that helps. I'll try to post some more of these, but that should get you started for now.